Hello, this is Britt Caswell with another example video. This is example 1 from lesson 1-3 in the SavvasRealize Algebra 1 textbook. This example is covering solving equations with a variable on both sides of the equation. So the first thing that I do, because these things can get really long, is I always start by drawing kind of a river down where my equal sign goes. Okay, that river is there to remind me that I can't have anything crossing that equal sign without using an inverse operation to cross the river. Alright, so if I want to move x's over or I want to move constants over, I have to make sure to use my inverse operations. So kind of the main premise of these problems is that we want to take everything that has a variable and we want to move it to one side of the equation, and then everything that doesn't have a variable we generally want to get to the other side of the equation. Alright, so in order to do that, I usually have to kind of strip away any grouping symbols, like those parentheses that you see on here, or sometimes I like to collect like terms because then I don't have to move as much stuff around. Alright, so those are the first things that I'm going to do. Okay, I'm going to start by using my distributive property to get rid of this set of parentheses. So I'm taking -2 and I'm multiplying it to each value inside the parentheses in order to drop the parentheses. So -2 times x is -2x. -2 times -4 is a +8. Alright, so now my equation, now that I've done that change, is still the same on the left-hand side. And then this +9 falls down. Now, the next thing that I tend to do is I tend to collect up my like terms. Okay, that saves me the amount of things I have to add and subtract. So here on the left-hand side, I have a 3x and a 4x. Adding those together, I get 7x. Now I cannot come to this right-hand side and add that or subtract the 2x from these. Okay, you cannot collect across an equal sign. I will eventually use inverse operations to combine it over there, but in this collecting phase, I don't deal with that 2x yet. Alright, now on the right hand side I have a -2x, and then my +8 and my +9, those are like terms, right, because they don't have any variables. So I can just go ahead and add those together and call it a +17. Alright, so now I've gotten rid of all my like terms. I have gotten rid of my parentheses. So now we're at the point where we want to kind of move stuff to other sides of the equal sign. Now, it's probably kind of strange, but I usually prefer to keep the number in front of x positive. Alright, so I could subtract the 7x to the other side, or I can add the 2x to the other side. Either way works. But what I'm going to do is I'm going to add the 2x to each side of the equation. That way, this number in front of x stays positive. Alright, so this turns into 9x minus 10 equals 17. Notice also when I add or subtract things to the other side, I'm kind of stacking those like terms underneath there. Right? I can't subtract the 2x from the 10 doesn't have an x. So make sure that when you add or subtract that you're doing it to the correct term and that it has the same variable to the same power. Alright, so we're back on our track trying to get the x by itself. So now I'm going to add 10 to the other side because you have to get rid of subtraction before you can get rid of the multiplication. So there I'm adding my 10 over. So I have 9x is equal to 27. Now 9x, that is 9 times x, okay? So that is a multiplication situation that's happening. And in order to undo multiplication, I'm going to divide both sides by 9. And that gives me x equals 3 as a solution. Now it is good practice to go through and check your work. Okay, so I'm going to go ahead and check myself so I don't wreck myself. So everywhere there's an X, I'm going to plug in a 3. Now notice when I'm plugging that 3 in, I am putting it in parentheses every time I do that. And the reason why is if I have a negative, okay, if I had a negative 3, it could completely change the outcome of the problem. So it's always best practice when you substitute something in there to make sure that you put it in parentheses when you substitute. Alrighty, so let's take a look. So here, 3 times 3 is 9, minus 10, and then 4 times 3 is 12. On my right-hand side, I have a negative 2 times, and then 3 minus 4 is negative 1. Notice I'm satisfying the parentheses before I multiply. And then I'm adding 9. So on my left-hand side, now that I've done the multiplication step, now I can go ahead and just collect all my like terms. So 9 minus 10 is negative 1, plus 12 is 11. On my right-hand side, negative 2 times negative 1 is a positive 2. And I get that 11 is equal to 11. So we are good to go on that. Alrighty. Now if you had plugged back in and you got something like that was false, like 11 equals 7 or something like that, that's telling you that you either made an arithmetic error or that this would not have a solution. Let's try another one. So I always start out, I'm going to draw my little river at my equal sign. Now notice that in this problem we have a set of parentheses again, and next to that parentheses we have something being subtracted. Alright. Now there's multiple things that we can do, but what's making me nervous, which I'm sure will make you guys nervous, is there's a fraction here. And most people get really uncomfortable when we have fractions. So I'm going to show you guys a trick to get rid of the fraction. So what you're going to do is you're going to take that fraction and you're going to flip it upside down. So here I have 1 over 2. I'm going to change it to 2 over 1, which is just the number 2, okay? And so I'm going to multiply both sides of my equation by that number 2. Okay, so there's my parentheses, and I'm timesing by 2. Now make sure when we do this that we distribute to each term, okay? So I'm going to do 2 times this first term, and then 2 times that second term. And same thing over here, okay? So 2 times 1/2, they cancel out, leaving me with just the n minus 4. And then 2 times negative 7 is negative 14. On my right-hand side, I have 2 times negative 2n is negative 4n, and then 2 times 6 is 12. Alright, so now we got rid of the fraction. B, we got rid of the yucky parentheses. And now we're back to kind of a simpler problem. So I'm going to go ahead and collect my like terms. On my right-hand side, I have a negative 4 and a negative 14. That's a negative 18. So this problem turns into n minus 18 equals. On my right-hand side, I don't have any like terms, so I'm going to leave it as negative 4n plus 12. And now we're at the point where we can start kind of moving stuff to other sides of the equal sign. So I want to get a positive value in front of my n, so I'm going to be adding 4n to each side of the equal sign to get rid of this minus 4n. Remember to make sure that you're combining only things that have the n's. So this turns into 5n minus 18 equals 12. If you're wondering where the 5 is coming from, remember if you just have a letter by itself, there's an imaginary 1 sitting in front of it. My imaginary 1 isn't drawing so hot. There we go. There's my imaginary 1. So 1n plus 4n is the 5n. Alright, and then I have a minus 18, so I'm going to go ahead and move that over by adding it. So I have 5n equals 30. And that 5n, that's a multiplication, right? So to unmultiply it, I'm going to divide, giving me n equals 6. And then we always want to check ourselves so we don't wreck ourselves. So here's where I'm going to go ahead and plug in the 6 where all the n's are. So I have 1/2 times 6 minus 4 minus 7. And then I have -2 times 6 plus 6. Okay. Don't forget when you put your 6's in, when we substitute, to make sure to do it in parentheses. Alright, so I'm going to solve inside that parentheses first. So I have 1/2 times 6 minus 4 is 2 minus 7. On my right hand side, -2 times 6 is -12 plus 6. I forgot to draw my river, so I'm going to do that real quick because whew, there's a lot of text on this screen. Alright, so now I'm going to go ahead and finish my last bit of multiplication here. 1/2 of 2 is 1. So this side turns into 1 minus 7. Here on this side, I can keep it as -12 plus 6, or I can just combine them right away. So left hand side, 1 minus 7 is -6. Right hand side, -12 plus 6 is -6. So my check is good. Okay, that means that 6 was my actual solution. Alrighty, so now this part here is the try-its. So I'm going to go ahead and pre-draw my rivers. These ones you guys might feel a little anxious about because they have decimals. Don't worry about decimals. They ain't so bad, alright? So our first step, right, we have sets of parentheses that are in here. And before we can solve anything out, we have to get rid of them. So to get rid of those parentheses, I'm going to use the distributive property. Alright, I'm multiplying the stuff that's in the front to the stuff that's in the parentheses so that the parentheses go away. So when I go to multiply, 100 times z is 100z. 100 times -0.2 is negative, scoot those zeros over, 20. Now, z's can be really hard for kids in algebra. So notice when I drew my z, I put a line across it to remind myself that it's not a 2. Alrighty, now over here, -10 times 5z is -50z. And -10 times a positive 0.8 is -8. That's not a decimal, that's just a -8. Miss C Stucks at the quick maths. Alrighty, so here we go. We have an equation, all the like terms are collected. There aren't any more parentheses anymore. So now we're going to start the process of moving things back and forth across the equal sign. So I'm going to start with my variable. Alright, I want to have a positive z value. So I don't want to subtract the 100 over there. Okay. Instead I'm going to add 50z to each side. So 100z plus 50z is 150z. And then there's still the -20. And over here there's still the -8. Alrighty, and then to continue to get the z alone, I'm going to get rid of this -20. So I will add 20 to each side of the equal sign. So I have 150z is equal to -8 plus 20 is a positive 12. Alrighty. So then my last step is to get rid of this 150 that's in front of z. Alright, so to do that, right now it's being multiplied. So to unmultiply it, I'm going to go ahead and divide by 150. So this turns into z equals 12 over, 12, not 120. Calm down, Missy. Over 150. And then I'm going to reduce that fraction. Now, because this question was given to us in decimals, I would probably be fine with us answering in decimals. Okay, which is what I'm going to do here. Now, I'm a little bit of a mathematics purist in that I don't like answering things in decimals. I like keeping things in fractions because they're easier to work with. So for me personally, right, I would reduce this. I know 12 and 150 are both divisible by 6. That would give me 2 25ths. So I prefer 2 25ths over 0.08, but both answers are equally correct in this case. The only time when it wouldn't be is if you get like a repeating decimal. Say you get like 1/3. 1/3 is not 0.3. Okay, 1/3 continues on for forever. It's 0.3333333. And if you have to use that for a further calculation, you can't in your calculator type 0.3333333 for forever, right? So there, the 1/3 would make it easier. Just kind of a heads up. I didn't really leave myself room for a check step, so we're just going to say that we're good for now on that part. Alrighty, so now let's check on this next one. Alright, we have sets of parentheses. So we're going to want to distribute in order to kind of simplify those parentheses. So 5/8 times 16d. Okay, I know there's going to be a d. Remember, a fraction is just division, right? So I can do 16 divided by 8, that's 2. And then multiply that times 5. That would give me a 10. Or you could plug 5/8 times 16 in your calculator and you'll also get 10. Alright, let's look at that again with the 24 now. So 24 divided by 8 is 3, times 5 is 15. Alrighty, and then on my right hand side, 6 times d is 6d, not 60, but 6d. And then 6 minus 1 is a -6. Don't forget there's the plus 1 sitting outside from the equation. Alrighty, and then we want to go through and collect our like terms. So my left hand side does not have any like terms. It's going to stay as it is. On my right hand side, there's no like terms with the 6d, but then -6 and the plus 1 are like terms. That's a -5. So now there's no parentheses. My like terms are collected. Now we need to start looking into moving things across our equal sign or our river. Okay. So first, I'm looking at the d values. It's probably better to subtract the 6d over, because that keeps us with a positive d value. So 10d minus 6d is 4d plus 15 is equal to, and then I still have a -5. And then we want to get rid of the addition and subtraction that's on the other side. So I'm going to subtract the 15 over, trying to get this d by itself. It's called isolating the variable. So I have 4d equals -5 minus 15 is -20. And then we remember that this is actually multiplication, so to undo the multiplication, I divide by 4. So then that gets me D equals -5. And there we have it. That's just a few examples on how to solve when a variable's on both sides. Don't forget, it's always helpful to check your answers when you have the space for it. And until next time.